Today, we're going to start Chapter 13. Chapter 13 is going to bring us into, hopefully, the point that you left off in Part 1 with the nerves. Hopefully, in Part 1, you learned the different structure, the components, I guess I should say, of a nerve. Hopefully you learned that we have an axon, we've got the terminal ends, we have our neurosoma, which is the nerve cell body, all the little dendrites, okay? So hopefully you learned this structure. The other thing, one of the things that we're going to run into, we're going to learn today about whether we're going to be looking at nerve cells in our central nervous system, which will be the brain and the spinal cord, or whether we're going to look at nerves, spinal nerves, that exit the vertebral column. That is going to affect their wrapping. This myelin, okay, that's going to play an important part in their structure. So this particular chapter, we're going to touch on the spinal cord, which is a part of the central nervous system. We're going to look at what is termed the spinal nerve. That's going to actually be the part that exits the vertebral column. So as you look or think about a spinal nerve, and unfortunately, this right here is not the best representation, but it is letting us or giving us an idea of what we're going to talk about. One of the things about the brain and the spinal cord, both of these are encased in bone. They are very well protected because one of the things that happens, their myelin is different. Are you new?
Yes, ma'am.
Okay, when did you get out?
2 days ago.
Be sure to talk to me and break time. Okay, so the spinal cord, it's encased in the vertebra. This is trying to show you right here, all these little things that they're trying to show extending out, okay? That's our spinal nerves. The wrapping, the myelin that's going to be around these is different. This is the one that is wrapped based upon the myelin. That's going to have the Schwann cell and does this huge chunk of wrapping all the way down the axon. Let's think about why that might be the case. Spinal cord, encased in bone, very well protected. Myelin, okay. We've got what we call that gray matter, okay, a lot of it in this area with the brain. But now, this nerve that's going to exit, if we look at the spinal cord, it's going to do this number. It's going to come out, and it's going to continue going around and around and around and down and down and down and down. Why do you think it needs that myelin that's wrapped around it in chunks based upon the Schwann cell? Well, now myelin helps with the speed of transmission, but this myelin is thick. This myelin has that Schwann cell that laid it down and wrapped all around it, okay? Don't forget, I said no electronic devices. I see some computers out. Yeah, no electronic devices. Why would you think that this nerve that has to exit the vertebral column needs that wrapping?
Protection.
Protection. This nerve is not encased in bone. This is the nerve that has to come around, and innervate everything for the body. And there is no protection, okay? Not by bone anyway. It's protected by that myelin. Because think about it. Okay. They say, when I say they, the people that tell us about the weather, okay, they say that, something's coming this weekend, all right? You might hear somebody go, oh man, I do believe it's going to rain or something because my sciatica's hurting. Okay, y'all ever hear somebody say that? Why do they say that? What is it about that sciatic nerve?
It's exposed.
It's exposed. It has exited the vertebral column. It has to make its pathway and journey down the lower limbs. And walking, running, sitting, whatever activities might be done, have the ability to affect it. And because it is such a huge nerve, and I mean huge, it's one that's most injured. So that myelin does offer protection, but not 100%. However, in looking at these differences, okay, we're still going to be having to pass information. That information has to travel up and down my spinal cord, meaning somehow it's going to cause a reaction. I like this picture right here because very similar to what you studied in muscle. We're going to talk about these nerve cells and their parts because they're going to have the fibers, okay? And those fibers are going to be wrapped and so on and so forth. And this is showing how they are in bundles. Do you remember how muscle cells were in bundles and they had all those wrappings like the endomysium, perimysium, and so forth? Well, this time, because we're in the nerve cells, it's going to be the neurium, like endoneurium, perineurium, and so forth. So this is showing a cross-section between two of the bundles with their fascicles. So it's a good representation. So when we look at this system, and we're going to stay in the nervous system for quite a while, unfortunately. For the spinal cord functions, send information up and down that cord. Well, now, wait a minute. Let's identify what information. What kind of information am I referring to?
Like body actions and stimulus that the body may receive.
Stimulus. Well, hold on. Let me think about this for a second. What type of stimulus?
External.
Senses,
External?
like senses, touch.
What are our senses? When I was growing up, we had 5. Okay? We have 6 now. All right? What are they?
Sight.
Sight, taste,
Smell.
smell, touch, hearing. What one have they added? Equilibrium. Equilibrium. Because we've got these little sensors in our joints and our muscles that let us know our place in space. Now, at this point in time, let's think about the general sense of touch. Meaning, everything that's to this environment with our skin and our skeletal muscles, okay? When you were looking in, I think it was chapter 5 or 6, the integumentary system, do you remember all these different accessory parts that were listed, like corpuscles, like Pacinian corpuscles and Meissner's corpuscles and so forth? We have all these like receptors that are available, and they transmit information. They transmit a lot of information, really. And if we think about this external information, that information, all information in reality, which we'll learn, has a receptor. Meaning, to this portion out here, it's getting received. But if this portion that's out here is receiving it, where does that information go?
Doesn't it go up the spine to the brain?
I got to get that information to the spinal cord, and from that point, we have to either integrate at the point of the spinal cord, get to the brain, and then what happens? If I sent some information in about, okay, let's think about that hot plate that we saw in the lab stuff, okay, and I touch that hot plate. Do I just simply remain on the hot plate like this?
No.
Okay, I get the response. I get the response that has to go which way?
Down.
Down. And it has to go out to what is termed an effector. E-F-F-E-C-T-O-R. The effectors of our body are either muscle. Don't forget, we've got 3 types.
Skeletal.
Muscle.
I'm talking about muscle. I'm talking about
Well, skeletal,
the muscle.
cardiac, and smooth. So we've got the 3. Muscle, glands, types of glands.
Secretion.
And
Maybe secrete that or something like that.
what types?
Thyroid.
Okay, which would be part of the endocrine system.
Mm-hmm.
But the secretion. What kind of glands of our body secrete stuff?
Like mucus.
We got like mucus. How about sweat,
Tear.
oil? Okay, so effectors are going to be muscle, glands, or organs. That's what's going to carry out the responses of information that got sent in. So we take information, we send it up the spinal cord. Somewhere we have to integrate it. Integration can occur in either the spinal cord or the brain. After we integrate it, we need the output, the response. Some of the activities that we carry out, our body and some of these really deeper muscles that we have, ones that we didn't really learn about in part 1 because they are